Hello everyone. Today's topic is periodic table. Here I have given a periodic table collected from website of Royal Society of Chemistry. So what is periodic table? The tabular display of all elements based on periodic properties is called periodic table. In the periodic table there are some horizontal rows. Those are the horizontal rows and the vertical columns. Vertical columns are known as groups and these horizontal rows are known as periods. So in the modern periodic table, there are 18 different groups named as 1, 2, 3, 4 like up to 18 and 7 different periods 1, 2, 3, 4, 5, 7. So in the period 1, there are only two elements. One is hydrogen, another is helium. Both are gas. The electronic configuration of hydrogen is 1s1. That means in the first orbital, one electron is available. Helium 1s2. And in the second period, 18 elements: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Same as in the third period, there are 8 elements: sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. But in the fourth and fifth element, there are 18 elements, and in the sixth and seventh, there are 32 elements. There are also two other periods the below of the main periodic table. First one is called lanthanide because first element is lanthanum, and second series is known as actinide series because first elements is actinide. Those two lanthanides and actinides, also known as A block elements, when I will discuss the classification of elements based on electronic configuration, I will show those things. Now, what is the basis of this periodic table, this modern periodic table? There is a periodic law. The physical and chemical properties of elements are periodic function of their atomic number. So, periodic table is arranged based on atomic number. The modern periodic table, because we see that in the hydrogen atomic number is 1, helium 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10. So it's serially placed on atomic number. That's why periodic properties also varies on this atomic number. But if we look for the story, this periodic table arranged by Russian chemist Mendeleev, who considered atomic mass for the arrangement of periodic table. He also placed same elements in a same group, similar properties elements in a same group. He also kept some place empty because that time those elements was not sure, but he predict and suggest some properties of those elements after then those has been discovered. At the same time, to place the elements in the periodic table, if we see in the main modern periodic table, we see in the first period is only 2 elements. In the second period is 8 elements. Third periods contain also 8 elements. Fourth and fifth periods contain 18 elements. So what is the logic or what is the chemistry behind these two places? Why the first period contain only 2 elements, second period 8 elements, and fourth elements 32, or sixth periods 32 elements. To describe those things, we have to know the electronic configuration of the elements. To describe the electronic configuration of elements, we have to know the Above principle. Just simply I can say the Above principle. The electron goes to lower energy state first, then go to the higher energy state. To write the electronic configuration, we have to know the orbit and orbital. Orbit means shell, so this is the first orbit, this is the second orbit, so third orbit, fourth orbit, and S, V, D, F, those are orbital. So in the first shell, only one orbit, that is S, and S orbital contain 2 electrons. That's why in the first period only 2 elements has placed, but in the second shell we know it might have s orbital and p orbital. The maximum capability of s 2 electron, p is 6 electron, so total in the second shell total electron capacity is 8. That's why in the second period also 8 elements is placed. So we can simply explain why the first period to second period contain 8 elements, third period also like this. Now we can focus on the elements of groups. The first groups, as I told, except hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium, all are alkaline metal because hydroxide of those metals are strongly alkaline. They are highly reactive, monovalent, and soft metal. In the group 2, there are 6 different elements. Those are known as alkaline earth metal. Hydroxide of those metal also alkaline, and they are available in the earth, especially beryllium, magnesium, calcium, strontium, and barium. But radium is not stable because this is radioactive. In the third group, scandium, yttrium, and lanthanide and actinium placed in the below. So sometimes they are not considered in the third group element. The fourth group also contain 4 different elements: titanium, zirconium, and others too also. Those are transition metal from scandium to zinc. That means from group 14, maybe group 12. Okay, after group 12, so group 3 to group 12, those are transition metal and d block elements also, because last electron has go to the d block orbital. So we can say scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Those metals are the d block elements and transition metals. Why they are called d block? Because last electron goes to the d orbital where we write the electronic configuration. This is the 13th group. So beryllium is the first element of this family. Aluminum, those are metal. So whose elements are metal, whose are non-metal, I can show from here, because okay, those are metal. Here hydrogen is non-metal and gas we know, and after this those are metal, all those scalar compounds. Those are not sure yet, those are metal or non-metal. Those are unknown because those are newly discovered and updated in the modern periodic table. And other elements: carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, argon, selenium, bromine, krypton, iodine, xenon, and those are non-metal. And in the group 14, this is carbon, silicon, germanium, tin, lambam, that means lead, is placed here. So this is the carbon family group. And 15th, nitrogen, phosphorus, arsenic, antimony, bismuth is placed here. And in the 16th group, oxygen, sulfur, selenium, thallium, folium is placed here. So the oxygen family, first member of this group. And 17, group 17 have a special name. This is known as halogen, fluorine, chlorine, bromine, iodine, astatine. Those are highly reactive, non-metal, and outer shell have only one electron shortage, so it can react so easily. And here in the group 18, those are helium, neon, argon, krypton, xenon, radon. So those are inert gas, because usually the outer shell is full, 8 electron in the outer shell, and they would not like to react any other metal or non-metal, even they are not from molecules at ordinary condition, so they are called inert. So I have shown the whose are metal and whose are non-metal. Now I can show whose elements are solid in the ordinary temperature, which are liquid, because room temperature is usually 25 degree. So the 25 degree centigrade, we can see the liquid only bromine, mercury, and francium only at room temperature, though these are liquids. Though mercury is liquid, it's the only metal which is liquid at room temperature. And gas is stays at room temperature. Hydrogen is well-known gas, nitrogen, oxygen, fluorine, those are gas. And inert gas, helium, neon, argon, krypton, xenon, radon. And these are still unknown what actually those are radioactive, so nothing to need to say about this thing, those are solid or liquid. Here there are other one group, that is copper, silver, gold. Those metals sometimes known as coinage metal, because these are alloy used for making coin from the ancient period. If we tell the details of element, here the hydrogen, so all those boiling point and some other all those things available here. I think the introductory of periodic table is after this. In the next lecture, I will describe all the properties of all elements and periodicity in the next lecture. Thank you for listening.